KW intersections, and we will have two talks today. In the first talk, Nafisa Ansum will be discussing GraphWrangler, and that's a tool that they built to extract graph databases from relational databases. Give her all a nice welcome.
Ansum, first year master's student at University of Waterloo. Currently working under Professor Singh. So today I'll talk about this software GraphWrangler that we are building at the Data Systems Lab. Professor Daniel Vogel from HCL Lab is also collaborating with us in this project. This work is published in SIGMOD this year as a demo paper. So I'll talk about after the portion we published in the demo paper actually. So I have to make sure, can you hear me properly?
Can you talk a bit louder?
Oh, okay. That's what I thought.
Oh, sorry, wait,
Okay.
let's see. Do we have a microphone?
So as you know, this is an age of connected data, and in many application domains such as road network, social network, e-commerce, these data interconnections can provide significant insights. And graphs are the most natural way to represent these interconnections. That is why people are getting more interested in representing their data in a form of graph to visualize their data interconnections or to perform in graph-related tasks. And there are many software especially designed to perform these graph-related tasks. And people are finding a lot of value using these software. But in reality, a lot of data in enterprises that we naturally think of as graphs are stored in a tabular format, sometimes in a CSV file or Excel sheets or maybe a log file or obviously in RDBMS. So what people do is people extract their graphs out of these relational data systems and then put it into a graph structure before doing any graph-related activities. So to convince you more, let's look at this survey paper done by my colleague. In this paper, extended version of this paper, they interview 8 people and 8 people who works with graphs, and all 8 out of 8 of them say that their main data storage are not graph storage. Their main data storage are actually RDBMS. So they extract their graphs out of these RDBMSs before doing any graph activities. There are some other interesting observations from this paper. For example, all of the enterprises model different data that we naturally think of as graphs. For example, let's say the product customer order database, we think of as a relational tables naturally, right? So they also convert these naturally think of tabular data as graph to perform to build fraud detection or find recommendation systems or find patterns, etc. So they are converting different types of data as graphs too. And in other question, among 33 participants, they asked if they replicate their data or they have their data, graph data basically, in multiple format. And they say 25 of them say that they do have their graph in multiple formats. And 8 of them actually didn't respond to this question. So from this observation, we can say that people are storing their graph in multiple formats and obviously extracting their graphs out of that format before doing any graph analysis or graph related tasks. So we made an observation that graphs are nothing but another view of the already connected data that is stored in tabular data format or another data format. So that leads me to the next question. Why people are not using this tabular data directly? Why they are interested in using this graph software? So one obvious answer is to if we see a data interconnection as graph, that comes to us naturally, right? So we can have like more insights if we see the data connection as graph. Otherwise, if we see the tabular data, it doesn't make more sense. So people are obviously very interested in having their, like visualizing their data connection as graph. That is one. And another thing is, if we want to do any graph-related like algorithms, if we want to perform any graph-related algorithms like PageRank or shortest path, and enterprises are like frequently doing finding patterns in data, right? So for these activities, if you perform these graph search activities in tabular data, it will be like troublesome or not very efficient. So I guess that is, for these benefits, users are more interested in, even if they have to replicate their data or have the trouble to extract their data out of the relational system to work with graph system. They are having this trouble and also performing these activities. But converting data from other systems are not very easy. It involves an ETL pipeline that is labor intensive, time consuming, costly, and sometimes, and not sometimes, like most of the time, requires programming skills which are not present all the time, right? So we asked, what if we build a system that lets user connect to their database and immediately get a graph view and have an easy and streamlined way of converting their data into graph. So with this motivation, we built this tool, GraphWrangler, that lets the user wrangle graphs out of their relational tables. So here we are using the term wrangler from the famous paper, Data Wrangler. So in the Data Wrangler, they convert other file format into a tabular format. So here we are converting tabular data into graph. That's why we're calling it, like we're calling this transformation as wrangling. Okay, so I'll give a short overview of how you can like extract your graph easily with this tool, and then go into the technical details. So this is the interface that GraphWrangler has. Using this interface, user provides the database information, and then after providing the information, GraphWrangler connects to the database and extract database information like tables, columns, column types, foreign key relations, and do a little bit of analysis of what kind of connection exists in the database to make it faster actually. Next, next a user can define, create nodes, like define a node by selecting columns from the tables or specific rows and use a simple drag and drop to create a node. I'll give you a demo like how to do it actually. So here you can see that a user created sticky nodes, and to define an edge relation, GraphWrangler uses a predictive interaction framework, which is actually a user given example, and GraphWrangler tries to find out why the user gave this example. For here, user draws an edge between two nodes, and GraphWrangler tries to find what kind of relation exists between these two nodes, and then show it in front of user as a model, and the user then select the appropriate, like the relation the user wants, and then thus it can define an edge relation. GraphWrangler also supports node and edge properties. It can define using the interactive framework. So the properties includes like aggregations and column values. So when you're done defining your graph, you can export. You can click on this button shown on this picture, and export and like download the export script, like auto-generated SOP script that you can run afterwards to convert your whole database into a graph. So okay, so every user action on the interface is mapped to the internal data transformation language. The data transformation language is a subset of SQL, having select, join, aggregation, filter, some filtering attributes too, and which actually converts the relational tables, columns, rows into like graph having nodes, edges, and properties. So, so I will show you a short demo of the possible application of this GraphWrangler tool, and then I'm going to graphical details.
This video demonstrates GraphWrangler, a system to query, explore, and transform relational data through the interactive creation and manipulation of graphs assisted by a predictive interaction framework. Our first demonstration shows the overall system workflow where an analyst investigates a fraud report from a customer named Alice. To investigate, the analyst connects to a database with tables for products, customers, orders, and merchants. They search for Alice in the customer table and drag the corresponding row to the graph to create a node for Alice. Next, the analyst searches for a product that Alice recently bought, a Tactics Bravo smartwatch, and creates another node. They draw an edge to explore relationships between the nodes. The system suggests possible rules connecting the two nodes. One is that Alice ordered a Tactics Bravo smartwatch. From this relationship, the analyst explores the neighborhood of first-degree nodes showing other products Alice purchased, and second-degree nodes showing other customers who bought the same products as Alice. This reveals a suspicious bipartite clique. To investigate further, the analyst notes the merchant ID in the product table and searches for that merchant in the merchant table. Then they drag the merchant to add a merchant node to the graph. Drawing an edge from the product to the merchant defines a relationship. In viewing this merchant's first-degree neighbors, they see it's likely fraudulent, since it's selling all of the products in the clique. Our second demonstration.
Okay, let's move into technical details. So to define a node as it's seen in the demo, you have to select first the column of its table, like from the column the value you want on the node, and then an appropriate row that value you want. Okay, sorry. Okay, so you have to first select a column and then appropriate row, and then you can drag that selected portion and drop it into the panel to define the node. For example, if you want to have like a Tactics Bravo node, you can select the description column and any tuple with Tactics Bravo on it and drop it into the panel, and that will generate a Tactics Bravo node. Okay. I have a better example actually. So suppose you want to have a gender node. So you select the gender column from the customer table, and then like you want to have the female node. So any row with a female value on it, then you can select the row and drag the selected portion and drop it into the panel, and that will generate the female node. So GraphWrangler interprets this as every distinct value for this column will be a node. So for gender node, other node will be like male node, for example. If you select the whole row, then it will mean that you selected all the columns automatically. So you can see that here we have a customer node Alice and a product node Tactics Bravo. So every node is associated with three properties: node types, values, and node lineages. So node type is basically the type of node, the specific type the node is, like customer node or product node. So node type includes relation name, like the table that the node is coming from, and the columns that you selected, like the value that are coming from the columns. And values are specific row value for the selected columns. For example, for Tactics Bravo node, we select only the description column, so the value is Tactics Bravo. For Alice node, we select the whole row, so the value comes from name equal Alice Smith, gender equal female, city equal Toronto. And the third property is lineages. This is very important for this software. So lineages are for a node, that for the node value, all the other tuples that has the same value on it will be a lineage of this node. For example, you can see there are two tactics Bravo description in the picture. So these two row will be a lineage of this tactics Bravo node. For the female node, all the rows that have female on it will be a lineage of the female node. It's kind of like this. So Alice comes from only one row, so it has just one lineage. Okay. So to wrangle age, as I have said before, and so user has to define two nodes and then draw an edge between them. And what GraphWrangler tries to do is tries to find all kind of relation exist among these two nodes and show it to the user and even to the select. This is the process. So the relation that can have between two nodes is some kind of join. So these two nodes will have a lineage, and what our edge can be is anything that joins these two nodes. Like it can be another table, or it can be like self join of this another table or another two table, or it can go like forever. But we are limiting like two intermediate joins for this demo paper. So let me give you a couple of examples. So we have these two nodes, Alice and Bob, and these are the lineages of these two nodes. So you can see this Alice and Bob have the same city, Waterloo. So these two node lineages can join directly on the city column. So we can say that we can draw this coordinate graph, like saying that every node, every customer that are coming from the same city will be connected in this graph. And okay, this is a customer product purchase graph. So Alice bought this package Bravo, and we have another table called order in our system that stores every purchase history with like customer and product. So from these, so these two are the lineages, and that is the like portion of the table. So we can see that on the table we can see that Alice bought this product before. So there is a join exist, like order joining these two lineages. So anything that joins the node lineages can be edge definition. So we can draw this bot edge for this customer product table. Sorry, nodes. Okay. So let's come to the predictive interaction framework. So after drawing an edge, GraphWrangler tries to find every possible join that exists between these two node lineages. So it can be very exhaustive. So it tries to find these lineages interactively, like gradually tries to find the first like direct joins, then consider the third table that can join these two nodes, and it goes from there. And also it has some kind of optimization that I'm not going to talk in this talk to make it faster and keep it in the interaction time. And every suggestion that it shows have a rank associated with it. For example, the shortest join has the highest rank. If these two, like for example, the previous Alice and Bob node is joining on the lineages directly, so that will be considered as the highest rank. And also joining on foreign key relationship also considered on highest, like second highest. And the third thing is the number of joins found, like if the higher number of joins will be considered as a higher rank. Okay. So you can define some properties. Like GraphWrangler supports the node and edge properties. Node properties has column properties and aggregation properties, and for each properties it supports only aggregation properties. So for node properties, column properties is any column value of this node, like the column we selected before. For example, for this tactics Bravo node, we have selected the description column. So description equal tactics Bravo can be property of this tactics Bravo node. And for edge property, so aggregation properties, aggregation can be done on the node lineages. So it takes like the property name, the column on which the aggregation will be computed, and the function. It can be some average or maximum. For example, we can count the number of lineages that this Bravo has. Like in this case, 2. And also like total revenue. Like we can do a sum on some kind of property we have. So edge aggregation property is similar to node aggregation property, but the aggregation is computed on the join output. So for example, we want to see how many times Alice bought this tactics Bravo product. So we can see that there are 2 join exist in this database. So we can simply count. So Alice bought this product 2 times. We can simply do count star on the join output. So GraphWrangler supports every other aggregation that basically SQL supports. Okay, so let's look at the second demo.
To show adding properties to nodes and edges. Our second demonstration uses a national database of phone calls to show adding properties to nodes and edges to answer cuboid and crossboid queries. The user first creates province nodes by dragging one province from the caller table into the graph and setting it to show the lineage count. The system suggests inserting other province nodes too. After drawing an edge between Ontario and Quebec nodes, the system suggests possible relationships, and the user selects the one that joins the 2 provinces through phone calls. From that relationship, the user also adds an edge property for the total number of calls using the count of associated rows in the calls table. This property is displayed on the edges between every province. To perform a crossboid query, the user undoes the edges and adds a gender node from the caller table and adds the lineage count. After drawing an edge between the female and Ontario nodes, the user selects the relationship suggestion for calls made between females and Ontarians. As before, the user adds edge properties for the total number of calls, then explores the total duration of calls as a weighted bipartite graph to complete the crossboid query.
Okay, I'm going to first, I think. So when you are done defining your graph, you can do a little bit of exploration, or if you don't want to do any exploration, you can download that auto-generated script. So when you click on the button, it will show you the SQL queries that it is going to run, for example, for node queries or edge properties queries. So you can download the script and run it like later anytime to convert your whole database into a graph, and like put it into graph software to do graph related tasks. So for this demo, we are supporting GraphFlow, which is a graph database that we are building in the data systems lab. So I think that's it. So if you have any question, you can ask me.
You mentioned some optimizations for the size. Do you have any sort of limits that you've seen it operate on in terms of like the highest amount of data in the database? Millions, hundreds of millions, how many rows?
Okay, sorry. Limits on where? I mean, to show.
So say you're sort of exploring a SQL database with 100 million rows across 30 tables.
Okay.
Do you sort of know what those limits are, or it's okay pretty much anything?
So the thing is, our main motivation is like you use a small amount of data from your huge database, and to use that small amount of data to define your graph. So when you are generating getting your nodes out of the table, then we already have a small amount of data associated with that. So to find the relation is we now have a tree structure underneath, kind of like that. It's pretty fast actually. So we tested on the IMDb database, which has 31 million rows and 6 million rows in our table. It works pretty fast for the predictive interaction, because we are always dealing with a very small amount of data compared to the whole database.
Thank you.
So what is the reason to convert to a graph? I mean, is any advantages having a graph view rather than keeping the relational database and use the normal queries or normal relation operations? Yeah.
I'm sorry.
I mean, what's the advantage? Why you want to convert to a graph?
Oh, okay. So before that, we actually had, we still are interviewing people. So we learned that people are very interested having their data into graph format. Like people from other, not CS person, like biologists. I've talked to some biologists that use, those people use Gephi to visualize their CSV file into graph structure, kind of like that. But they cannot, they don't have the ability to convert, they can write script. Someone has written one script for them, and they're using that script so these tools are especially for those people actually. So that's what we aim. And people are doing using graph a lot. So I think mainly for data visualization, that's what we saw so far. And some people are doing finding patterns, are running graph specific queries. People are doing that. I don't know if I answered your question. That's what we found out so far. Okay.
Sorry. So about the question, I was wondering what is the advantage of Wrangler to other database to graph numbers like cytoscape or cytoscape?
So you want to understand
What is the advantage of what is the main advantage of GraphWrangler to other converters like cytoscape, as you mentioned earlier?
Okay, so the main advantage that we are thinking of is the interactive framework, so that you don't have to know any script and you can explore different possibilities. So I actually don't know about the software, to be honest. So it does have similar thing.
Yes. So far I know it also has a zero plugin. I was wondering because I was already experienced on that.
Yeah. So the people who don't want to write a SQL or want to explore what kind of relationships they have, they want to explore different data, different type of graph, I think this tool can be beneficial for them, especially if the person don't know how to write codes or yeah.
So the people you interviewed said they always use graphs. Did they say, did they give you use cases? What would they use it for? Your demo, you mentioned fraud detection or attestation.
Yeah, those are from the enterprise.
Right, so what else did they use it for?
Okay, so for example, I met one professor who uses bad data, like they have this small things inserted into bat, like the bird, and they want to analyze the social activity of the bat doing. So they have this new CSV file.
Social activities of
bat,
okay.
if bat has some kind of social activities like that.
Okay.
So under I think IT, someone ontologist, I think. He is doing some kind of cancer treatment, and he had a CSV file too, and he's interested in exploring the data, like seeing the data as graphs and some kind of work.
And what about on the enterprise front, companies?
Okay, so enterprise ones are, so that's from the separate survey from the, my colleagues did.
Oh, okay.
So they say that they want to, like, it was a survey like defined question. So they say they want to do finding patterns came up multiple times. Visualization actually seems to be very like popular among them, like data visualization, and also like fault detection kind of thing.
So your interviewees were mostly academic in your survey, and their enterprise and the other one?
For mine, it's both, like mostly academic and few. Yeah, you're right.
Can you go over how you define the edge definitions? Like, how do you pre-populate these correlations?
Okay. So what do you want to know?
So, like, how would the algorithm come up with those lists of relations, and would I be able to add my own correlation?
So you can, if you want, from the not found button, but it will actually capture a lot of relationships that you can discover, but it's generally a lot. Like it tries to find every possible way these two node lineages are joining, like among with different tables, with different column joins. So I'm not only considering the foreign keys, but I'm considering actually the key value join. So I'm matching the value on other columns. So it can basically find all the joins, but you can still define your like edge definition using the not found button.
So if I define my own edge definition, would it remember that the next time I have two nodes with the same code?
Okay, so I saw.
Yeah, I was just wondering if you could go out a simple way of making nodes from a lineage that combines two columns. So say if you wanted to have all your nodes be a combination of gender and problems.
Yeah, you can.
That's something that you can easily select.
I'm not sure what you asked, but let me clear it a bit. So if you select gender and province column, and like female and Toronto, a tuple with female and Toronto value on it, so your node will be every distinct value of this combination, like edge and province will be a node. Like female Toronto will be a node, female Ontario, not Ontario, female Montreal will be a node. Is that your question?
Yeah, no, I was just wondering if that was something you could do.
Okay.
Does anyone use this for analyzing the relationships with unstructured data? I can see the sense of having, using MySQL, it's easy to access, but if I had relationships in my database with foreign keys, I'd already know that order is significant across locations, etc. But if I was on Hadoop or something and I had unstructured data, then the discovery of this would show me the relationships, especially if you could annotate the ranking that is presented for the relationships. That would feed back on how I can create a relational model. Useful for visualization, but to means to do the engineering to build the schemas.
Okay, so you're telling me unstructured data as in like still a tabular data, but
It'd be tabular data, but I have no sort of understanding of the content of the actual cells, right?
yeah. Okay. Yeah, that would be nice. So still we are actually joining with values, not foreign keys. I'm
Yes.
ranking higher the foreign keys higher, but yeah, but you have a good point.
Yeah, so if I could actually see the data on the ranking, so I could see the strength of the relationships,
Okay.
especially if I could understand that they were first-class relationships.
Yeah.
You know, and then I'd want to see how complete the set mappings are. Is one set fully consumed by the other set? That would tell me there's a very strong foreign key relationship with the data.
Okay, yeah, it's a good idea.
Okay.
Yeah, thank you.
do you think is it a viable solution for big data? I know it's a repeat question, but do you think is it viable for big data?
I think so, because the thing is, so we are like always we are concerned with a small amount of data when wrangling. So what you need is a definition. This tool is just for ETL, not actually for exploration. So if you want to convert your data, so first thing you need to do is you need to define the graph you want. So this tool can be efficient to define the graph, no matter how big your data set is, because it will always work on a very small amount of data set. So when you have the script, you can run it outside. It will still take time, but
Well, I was assuming you were searching in the search bar. So if it's a big data, it's petabytes of data. Then how do you?
so for
how much time
example,
would be taking?
so for now I'm storing the lineages in memory, only the lineage. So I have the column values that are possible to join, right? So I'm only searching for those values, and I'm actually doing a little bit more that we can discuss after.
And one more thing, is it open source?
Not yet, but we are planning to do it soon maybe. So we are still working on this. This is the demo paper. So we are trying to find out the ways it can be more useful to people. So that's why we are talking to people. So anybody who works with Graph and has tabular data or any other data sources and needs to convert, you can contact me. I can learn a few things from you, and that should be beneficial for me. Okay, so.
Cool.
The X suggestions they're providing, are they in the sorting order of the rank?
Sorry?
The X suggestions it is providing, right? The X suggestions.
Yeah, the rank?
So is it in the sorting order of the ranking?
Yes, it is.
And can we customize the ranking
Not now. Not for this version.
Have you tested this other than MySQL or Postgres or any other big data like Spark?
No, not for this demo.
No, but this
It
system,
works with MySQL.
but MySQL is not distributed.
No, we don't have any system for this. It is just a demo paper for now. So we are working on the full paper.
No, not about the paper. I'm asking is the tool, if I connect it, you connected it in your local host database.
Yeah.
But if you connect it in distributed database.
No, it's not going to work
It's
very
not
well, I
going to
think. Yeah. But because the internal structure are not built for distributed system yet. Yeah.
But what is the difference between this one and Neo4j?
Okay, Neo4j is a graph database. This is a tool for the ETL part where you start your graph from your other data sources. That's the main.
So it's the
It's just for the ETL part, nothing more. Yeah. So, sorry.
This might be a silly question, but have you found cases where there are more than one edge definitions for two nodes?
Yeah, generally it's 18 or 20. This is, I'm just showing, if you scroll down the edge definition, I can show you this.
So this would
20 or
be order
30.
priority then?
Yeah,
Okay.
we're showing the rank list, but if you scroll down, it will show you because it's considered all the value join, so it's 30